Okay, so this looks very multi-threadable. 10 million positions. So I am going to add something that will do these positions with, I don't know, 32 threads or something like that. And that should make it faster. I don't know how much faster, but at least 10 times faster. Let me also add an maybe the I'm wondering whether we should use AI stateful task as well, because on this interface doesn't look very handy. Okay, I think this is the lambda that we add. It's just a lot of code to add it, but can I wrap this in some kind of object? I guess I could. And then I make I create an object. Yeah, it's not really true. It's not really an object. What's with the Q fool? I want to add 10 million tasks all at once. Is that not allowed? I mean, 32 here feels a lot like the number of threads. It's probably not. Hello, Surprise X. Oh, I have a better idea. I definitely don't want to add 10 million tasks. No, I want to divide the loop into smaller loops so I can divide them over threads. 10,000 maybe, or just one divided by 32. Well, no, maybe, yeah, I don't know. I wrote a program that analyzes king plus rook versus king on an infinite chessboard, and that takes hours and hours to run. So I'm going to add multi-threading now, using my own library. I mean, I have decades worth of code that I should reuse instead of reinventing it all the time. So this is my own code, description of how to use my own ThreadPool. What it does is just it adds a lambda here to the ThreadPool. So I'm thinking about how to change the chess code so this tiny loop here is say up till 10 million. So I want to divide this thing into, I don't know, a number. I think it doesn't really matter. Maybe I should not go for 32 or something. Maybe just divide it in 100 pieces. Feels like pretty optimal. Or just go for 10,000 or 100,000 at a time. So I do I just want to use my CPU, all the threads at the same time. So if I have a really well-filled ThreadPool queue, then all the threads will be busy. But if I make each task too short, then the overhead of adding the tasks, the whole ThreadPool itself overhead, increases. I think I'm good. I think it doesn't really that matter. I think I'm just can add between 1,000 and 10,000. Maybe 1,000 is better. But let's say I also have 1 million. Loops of just 1 million, and then I want those to be divided in 32 parts. So maybe I should go for loop sizes of 2,000 or something. I'm not really sure. I can make it variable, but I mean I can make it compile time, subcompile time constant. I suppose it doesn't need to be really be dynamic or something. I can just have a fixed number that I throw at each thread. I just don't know how much yet, but I guess it doesn't really matter that much. Okay, so I'm going to have yeah, it doesn't matter where I put that compile time constant. Down I haven't used another time. Maybe I'm just gonna put it here, I think. So the const expression int so this is then this loop size while looping over parents. It's more a number of parents at a time, something like that, per thread. A number of parents. Let's call it a task. A single task is something that you let one thread execute at a time. We're gonna do per task. Let's begin with 1,000. No, let's begin with 2,000. So I just reasoned that. Then I need to divide this into multiple loops. So that's not going to work. We need to run over the index of this thing. So the y to move parents is probably just a vector. Yeah, definitely a vector. But let's look it up. It's a standard vector. So index is an integer. Let's give everything a clear name. So we have a size type, const number of parents, a total number of parents maybe. Parents. And then this must be by index. So instead of running over it like that, in the end I need a board. Let me just run over, yeah, some index. So maybe we'll call it parent. Parent is less than or unequal. Well, it's an integer. Let's use less than. Number of parents. Plus parent. And a board is really small. It's just a wrapper around an encoded type, which is probably 32 bits or something. So maybe it's even cheaper to make a copy than and then to use a reference, which is 64 bits. So I'll just make a copy, and then when we copy from it was y to move, right? Yeah, this. Oh no, it was y to move parents is obviously the thing. Parent like that. However, now this whole thing I need to execute number of parents per task times. So I want to divide this loop into multiple loops for a start. So let's say first parent or parent start parent. Let's call it start parent. Start parent is definitely less than the number of parents, obviously. And then we increment the start parent with the number of parents per task. And now this thing just begins at start parent and then runs till start parent plus number of parents per task. However, the last one will now get over the number of parents, because that's probably not divisible by the number of parents per task. So instead, and I have to do that anyway, let's make a variable here. Call that end parent. I don't know. Now suddenly I feel like putting start at the end, and I can put end at the end, if you get what I mean. Start parent becomes a parent start. Let's put parent end, so one past the last one. Is then this by default, unless it is larger than. So it must be the minimum of those two, meaning number of parents, right? So this thing starts at 0 and then is incremented by 2000 every time. And this thing starts at wherever that one is at that moment, and then runs over 2000 parents. Unless we are this being 2000 and that being the start. Well, unless it's the last one where this value plus that value is already larger than this, then this would apply, and parent end just becomes the last, well, one past the last value that we shouldn't do anymore. Okay, now I now divided the loop into multiple loops, and now we want to run each of these in a thread. So to turn it into, well, what I would call a task. And then we can add the task to the ThreadPool. And then we have to do the same thing again down here. And I feel like doing that immediately. Save the number of parents, this time black. And then I have two loops. Can just copy it from here, I think. Oh, wait a minute. I didn't copy that. That should still be white, huh? Oh. Now, turning this into a task means I just need to make it a whole lambda and then execute the lambda. The parent end is also a function of which task it is. So you're going to have an auto task is, and just make a lambda. For the whole thing. And then we run the task. Ain't that right? But that means that we need to capture a lot of stuff. For example, parent start is required and number of parents per task and number of parents and yeah, why to move parents, definitely by reference because that's a big thing. Why to move board, also by reference. Oh, wait a minute. I think I'm writing to one of these things. I'm writing to why to move board. So now I'm running many threads which will write to this vector in parallel. That won't work. So either I have to add a mutex around that thing, or we let every thread write to its own vector. And then in the end we concatenate those vectors together. I think the latter is faster because, yeah, otherwise, you know, you take 2000, log 2000 times a mutex and unlock it again in a tight loop. And then there are 32 other threads that do the same thing. That doesn't feel right. That's just, you're probably going to have contention there. So threads try to get that mutex while it's being blocked all the time. So it's a little bit more difficult on this, but ignoring that for the moment, right, to move board. Is that the last one? Black to move parents. Let's do the black to move parents. Let me first, if it compiles, and at least have a list here of what I need. Let me try this one. Use of undeclared identifier why to move board. Did you mean why to move parents? No, I don't think so. Why to move board is not known. It's just this board here. So it's definitely does not exist yet. Graph itself, of course. What? There's no... probably different types. Well, they should both be size type. Why would that not be size type? Can I ignore it? Deduce conflicting types of parameter int versus size type. One of them is an int. Which one? Oh, parent start is an int. Yeah. Well, I think I'm just gonna make number of parents an int as well. I hate signed types. Everything an int. Graph cannot be implicitly captured in a blah. So yeah, the same problem there. Get info here. This is a non-const reference to an info, which means that we need a non-const graph, and then cross our fingers that we won't write to the same memory location. Is that going to work without mutexes and stuff? Pretty sure that. Yeah, the info is one-on-one specific to the board. And the board is defined by the parent index, and the parent indexes are unique. Therefore, each thread will only access unique infos, so there is no mutex necessary. Would be nice if they were all in separate cache lines as well, though, but let's not worry about that. Quite a lot already. I have to capture so much that it's probably going to do a memory allocation for it. But yeah, we'll leave, I think. That was the last thing. Apply cannot be implicitly captured in a lambda with no, we are using ply. Equals ply. Okay, so we can do that by value. Do that by value anyway. Oh, we need a capture bar. Might as well leave them the way it was. Just capture the same stuff in the same way. No. But okay, so now what now is wrong is that we are writing to this thing here. Let's go here. So the y to move board is being written to. I want to be sure. Hello, Jedi. There was a question. All the syntax. I don't know what you mean. I remember a lot and I don't remember it and I look it up. Yeah, so we have 1, 2, 3 references, and I just argued that even though we are writing to graph, so we take the non-const reference here, and graph is only really used. Oh, it's also used here, but still, I think inside here it's also used for get info. Nevertheless. So access info, access non-const info, unique for this thread. That's why we are allowed to use graph without locking. And here we pass graph as well. And yeah, graph is also here used to get an info. And I'm slightly confused here because this runs also against over on parents. What the fuck? Probably const anyway. Parent info. You're not writing to it, just being used to. Oh, actually, we do write to it. We set the number of ply on the classification of that info. And then we do the parents out pushback. So this is the problem here. Here we write to a vector, and if we do that for multiple threads, then that's no good. It will corrupt the vector. I'm just wondering what parents is this running over then? Number of parents equals generate neighbors. Oh, it's generating all possible parents here for that one position. But that one position is then, you know, one of a group of 2000. So they are unique, but the parents themselves don't have to be unique, unfortunately. So we have, say, 10 million positions. I cut them in pieces of 2000, and I run per 2000 in threads, a lot of in parallel. Each of those positions are unique, but the position from which we can reach these positions might be not unique. Okay, you have the parent position, and if you do one move, then you end up in one group, and if you do another move on the same parent position, then you end up in another group. So those two could be executed in parallel, and that means that the parent here could be shared between two different threads. But we don't write to the parent, it's a const, so that's fine. We just read from it. However, having this parent, we do access a parent info, which is non-const. So now it might happen that two different threads get a reference to the same parent info. And why would that work? Well, I think that works because of this. It was just the last child. So we only really write to it here, and that should be done for only one thread, because there is only one last child. So this must be thread safe now. And then it should return true for only one thread. And that one thread is then executing this single threaded. So we can add a comment here now. This is single threaded. Only executed for the last child. But yeah. What is necessary here is to make increment process children thread safe. And that increments something and then compares it with number of children, which is set in advance. I guess this is already initialized, right? So we have just multiple threads reading the same variable. No mutex needed for that. But this thing must be atomic, and it's an increment, so it must be a read modify, change to a read modify write thing. I'm gonna use a fetch. I think fetch add. Let's first make it atomic anyway. So I'm writing to classification, but you can feel that is, you know, thread safe by default, because the program is supposed to be efficient. I'm not going to calculate the same classification twice. So each classification is going to be calculated once, otherwise I would be wasting CPU already. And so we automatically end up with only a single thread calculating that. And likewise, I would say, yeah, of course, we are going to write the number of children only once, because why would I write it twice? If I wrote it twice, then I would already do that, which would be a waste. But let's check that anyway. So no, the number of children is being written to where. Because initialize should be single threaded as well. Number of children, this reads. Here it is set, the set number of children. Test. So who's calling set number of children and from where? That is being called from classify, which is totally single threaded still. Yeah, that's already in my mmapped file. So I'm doing that single threaded at the moment, but it's code that was already executed before even start the ThreadPool stuff now. So this value is part of the mmapped file at the moment. Pre-initialized basically. Right, okay, so this function has to increment this atomic and then return true if it becomes equal to number of children. And the number of children I can consider to be a constant, because that was already defined, assigned, whatever, before we start the threads. Therefore, we only have to deal with a single variable. This is completely self-contained. It increments it, compares it with the constant. So there is no synchronization needed. So we're just talking about the same memory location and not any other memory locations that are changed at the same time. We are using this memory location, but it doesn't matter which value we get in terms of reordering, because that value doesn't change. Since there is no synchronization, we don't need anything but just relaxed memory access. So I'm going to change all the places where this thing is being read to a load with memory order relaxed. No, that's not the one, this one. This should also only happen once. I'm not even going to change that. I'm lazy. This would work. You can do a pre-increment of an atomic, I think. Yeah, you get a previous value back usually. Oh, wait a minute. If I do a pre-increment, then I get the result back. I think you can only do a post-increment for an atomic. But yeah, I'm going to use a fetch add. Let me look that up. So the default is memory order sequential consistent, which I try to avoid, because on Intel everything is the same except sequential consistent. Then you insert a lock assembly instruction, and it's absolutely not necessary. On ARM it would of course be even more different, but even on Intel, I should say. The word even is more like for Intel. Even on Intel, you want to avoid sequential consistent, and the rest is all the same. In terms of assembly, resulting assembly code anyway. Unless you're an expert, you should use memory order sequential consistent. That's what they advocate. So watch YouTube from, say, CPP-Con or something like that, or any guru that teaches you, then they all say, please use sequential consistent because you don't know what you're doing. Therefore, you must use that. Anyway, it's a second parameter. I have this one. But fetch add returns, I think, the post increment. Yeah, the value immediately preceding the effects of this function. So the previous value. And I had a pre-increment, which means that I have to add 1 to this value. Or I can subtract 1 here, I guess. So this should return true if this was the last child. Well, if the previous value was number of children minus 1, then now it has ended up and did end up on number of children, and then it is the last value. Yeah. So here, this is debug output. So I'm not going to add a load memory order relax, or could do that as well, but who cares? So this is going to be executed with memory order sequential consistent, which would make it a nanosecond slower maybe, but no, it's debug output, so I don't really care, I guess. Okay, still this is not thread safe because all the threads use the same vector here. So we have to change that as well and pass, I think, a different vector. Just give every thread its own vector. Oh, do. Yeah, we can just put it on the stack, right? No, we cannot put it on the stack. I was going to put the vector on the stack here. That's nonsense, because the main thread that keeps running and then exits the loop, or even just goes to the top again, destroying that vector. If you take a reference of something, then obviously that must live until all the threads are finished. I'm gonna join all threads after this loop. So you could add something here, one something per thread, and then hand them out here, and then join the threads and then destruct that thing again. That should work. Did I already have this here the same? I think I did. I'm not sure about the last changes, but it still compiles, that's good. Right, so let's yeah, it's slightly problematic. I don't really have threads here. I have tasks, as you can see. I'm not sure if I want to have a vector per task, because there might be an arbitrary number of tasks. Okay, so the size now is 2000, and I thought I had 10 million, but yeah, there's only in this case. Eventually I'm going to have way more than that, I think. So maybe you should turn it around and calculate this from this. So if it is 10 million, we use 2000, or I just divide it by, I don't know, how many tasks shall I make? Something significantly larger, but not too much larger than the number of threads, aka 32. Let's say maybe 200 tasks. So I could just divide this by 200 and then assign that to that. And that means that then we will have about 200 tasks, and then I can make 200 vectors. That's not much of a problem. Yeah, let's do that. So actually then it now becomes a function of the number of parents, which is we got here. I'm gonna move this down therefore. Now I think I can just put it on the stack as well. So I can use an array here. I think a standard vector in debug mode is really big. But then it's a few hundred bytes maybe even. But then a few hundred bytes times 200, that still fits very easily on the stack. So just create a standard vector of a board, I guess. and then one for each task, the number of tasks. And that's it, then going to be the vector that we pass here, so the white to move board. Tag a task on it. It reads a bit weird though. It's more like a task white to move board. We have one per task now, and then I should do... what? Oh, wait a minute, that's not the one then. This one. This is what you write to. We have another check here. Yeah, the last argument is what you write to. Black to move parents here. Oh, and that is already something on the stack. What? And then where is that being used again? Oh, and that is being used here, right? But okay. So we're gonna have this and then one per task. And then we have to grab that. It's on a whole array, but okay, can take the reference to that. Though, actually here the task is already known. I think that I have to... Let's run over tasks. But I have task already used here. Task, I'm just gonna call T, I suppose. How many tasks? Is there no guarantee that I have this many tasks? I think yeah. No, actually, because this might also be really small. So I need a ceiling of this. Number of parents, but oh boy. I'm making a mess of it. Suppose we have less than 200 parents. Then this becomes 0. 0 parents per task is probably not a good idea. So this must be at least... what I should do is calculate the number of tasks first. The actual number of tasks. Let's call this maximum number of tasks. So this must be at least one, and if say we have 400 parents, then I want each task to have 200 of them, so then we have 200 plus 200 is 2 tasks. But if I would have, no, wait a minute, that's nonsense. I can still divide it by 200. I don't want to put one. I don't want to make this 1 or something like that, or 0, something like that. But there is also a minimum number of parents per task, which I should define somewhere. What is the minimum number of parents per task? 50. I don't know. Seems reasonable. So I was aiming for 2000, right? So 50 seems reasonable. Hell, I'm gonna make it 100. So now we have the minimum number of parents per task and the maximum number of tasks and the number of parents. And then to calculate the actual number of tasks and the actual number of parents per task. And then since this now is dynamic, we can no longer make an array of that. But maybe there is going to be a maximum. There's a maximum number of tasks. I'll just do a maximum number of tasks here for the size. That should work. And then it no longer can be a const. There must be a const expression. Might as well make this a const expression as well. I don't know. It seems to read better. Okay, so number of parents, that, yeah, number of tasks. Okay, let me think. That's a dual. So I guess the number of tasks is just this, but then limited on to that. That makes sense? Yeah, and also at least one. The number of parents would be one, then we still need one task. I keep forgetting how the standard clamp works. Let me find that again. Standard clamp. Low high as the last arguments. What is this? Why does it take a V here? Oh, it just returns V. Unless. Yeah, that's what I want. This is only an indication because it might not even divide. And so because this is just an indication, this is also a bit fuzzy. It's not really the number of tasks, but we have to just start creating tasks until we did all parents, and then we're going to do the parents in chunks of number of parents per task. So maybe I should do a roundup or somewhere. Suppose we have 3 parents and 2 tasks. I guess I'm happy with the rounding down, so I just leave it like this. So 3 divided by 2 would give me 1, and then we have 1 parent per task. And then of course we need 3 tasks. So this is a bit fuzzy then. And there's 2. So now we need a loop where we just add the number of parents per task until we're done. That would be be happening here. This is the only reasonable way that you can find out how many tasks you have. So we can't do this because I don't really know in advance how many tasks I have. At least this is the easiest way to get it. Just start looping. So I'm just going to do int task number. What is the best way? Task number, I don't know. Start it at 0 and then can I use a comma here? I think to work. Okay, and then we have to I could make a reference here to the vector, which is the black to move parents vector then for this specific task. I was going to call that this. So this is more like the plural of this because there are multiple of them. Ask black to move parents. I'm just gonna add an S. Okay. Okay. Shit. Okay, and then the task black to move parents is then this thing here for index task n. And that is then the one that we need to use. So grab the reference, or if it is a reference, then you still need to have a reference here, as far as I remember. So now the thing writes to a vector that is different for each task, making it thread safe. And nobody knows why S is being assigned here, because we don't even use that. Do I miss something? I don't think so. S, no. Okay. Probably easier to just copy everything and then swap black and white instead of trying to make this work. Trying to duplicate what I did rather. Yeah, okay, let's just finish this part and then I'm going to copy it, I think, and then change white into black and black into white. That should work, hopefully. At least this part then, from here to there, this part. And here is... and this vector still has to be filled. Yeah, that kind of sucks. I'm starting to think that maybe I can't even use, or should not use my ThreadPool. ThreadPools are a bit like fire and forget, and I can't really forget it here because I have to wait until all of them are done. So I could wait until the ThreadPool queue is empty, but I don't think I even have a provision for that. It would make more sense to just start threads, a lot of threads, because now I have at most 200 threads, and then let the kernel handle what otherwise my ThreadPool would be handling. Or can I just create a ThreadPool maybe and then destroy it? Maybe that will flush every task. No, not threads, tasks. Yeah, let's try to use the ThreadPool. ThreadPool. So I would have to add everything to this queue, which is going to tell me that the queue is full if I added 32. We have a maximum of 200, so I could use 200. It should fit. Is that really the upper limit though? The limit is how far this thing is counting, which depends on the this value. It's kind of like the number of parents divided by the number of parents per task and then rounded up. Thus, the number of parents divided by this, which is this, to a number of parents divided by this is the number of tasks and then round it up. That's mighty more than the number of tasks. Can it be like one more, or can it be more than one more? I have to use the same thing as before. This is 3 and that is 2. Then this becomes 1. And so this is now 3. And 3 divided by that, which is 1, is 3. So that is 1 more than the 2 that we had. I think it's just 1, just plus 1 probably. Which could theoretically be 1 more than max number of tasks, which should not happen, but nah, it's fuzzy. But okay, now it's never going to happen, but it is possible that the task runs full. So maybe the queue runs full, and I probably should just take that into account. But if I add 1, then maybe I can just forget about that part. And I'm just going to add an assert, I think, that the queue was not full. I mean, we're able to add everything. So how do we add stuff? That was with this complex code here. With this whole horrible block. So I have a ThreadPool. Did I name it like that? Probably. Yes. Get read access, and then you get a queue access, queue handle. So the other thing must be called queue handle, which you also called it. I think I'm pretty sure I called it queue handle. Yep. And then here is our boolean queue full, and that should never happen. If not queue full, do that, otherwise crash. Here we add the task, which is the lambda task. Well, let's add an assert here for queue is not full. It's not executed here. And that would add it, yeah. And then we go back to the loop, and I rapidly add all the tasks to the queue. And then we exit this one, and now here I want to wait. So here I want to wait until all tasks finished, or here, I don't care. What is this anyway? Just an end of a scope. Okay. Oh, let's do it inside the scope. Everything task key inside the scope. So here I want to join all threads of my thread pool. Everything that's running in the thread pool. And I can't remember that I ever would add that. Why would I add that, right? But maybe it has it. I don't know. So look. We have an action. Wait. The wait is part of the action. Try obtain duty. Woken up. This is starts on the semaphore. We have a priority queue defined. Task available. Duty. Quit. Oh. What? Okay, this is a struct. Quit struct or worker struct. Running. Set thread to running. Set thread to running. Quit. This seems to be talking. This is wait. This is inside. Oh, this is the worker still. Yeah. Worker is a thread. So this is my thread pool. Idle threads. Workers. Add threads. Remove threads. Queues. Thread ID of the thread that created and or moved AI thread pool. Current capacity of M workers. To this object was moved and the destructor should do nothing. The defer task queue. Color codes for all the threads. Change the number of threads, number of workers. Queues read access. Lock MQs and get access. Return values passed. Blah blah blah. Create a new queue. Get queue. Set maximum number of queues. Call update current timer. Defer. Color stuff. Instance. Absolutely nothing is allowing me to wait until the threads are finished. Is it easy to add? Is the next question. No, I could even have an empty queue already, and the threads are still running. I don't think we should be here. I think that I should just add something to our task at the end of the task. That will tell us when we are done. That is by far the easiest way. And I'm even not even going to wait until the threads are returned. I mean, these are tasks. They run in the background. The only thing I'm interested in is find the code first. What you are interested in is that the last task finished writing to their vector, and so we can collect all the vectors. So inside a given task, we do our stuff, and then this is the last line that the task will execute. I should just execute something here that tells the main thread that this task has been executed. In other words, decrement and counter. So let's call that thing number of tasks, and I'm just going to decrement it. Must be some kind of atomic. And then every time we start a task, I'm going to increment it. We probably should do that before actually adding it. So now number of tasks must be an atomic that we have access to outside of everything. But inside this scope, so I'll add it here. Atomic int. Call it the running tasks. And I would rather put it lower, maybe here. I always do pre-increment and decrement, but I don't think you can do that for an atomic. You can only do post. That's why I do it at the end now. So you have to capture that atomic, and obviously not by value. You can capture it by reference. So just before I put it on the queue, increment that number, and then it is at least incremented. It's the full number of times incremented before we even get here, because that is being done by the main thread. Yeah, the main thread is the one that executes this block. So the main thread in this side is loop. Increments the task counter here. I probably could have pre-calculated because, well, yeah, theoretically we know how often we loop here. Shall I do that actually? You know, I think about it. I don't know. Maybe I should just not be lazy. Although, if it fails, I mean, I'm gonna assert on it. But theoretically, if the queue is full, but in the end, I'm gonna have to add it anyway. I mean, the problem completely. I can't say like, oh, the queue is full. Let's not add the task. So in the end, I really have to add it anyway. And then I might as well set it immediately. So here we have the actual number of tasks. So number of tasks, I want to have the actual number of tasks, and then this is not the actual number of tasks. This is more an estimate. So let's rename this one into estimate. And then the actual number of tasks which also means that my task n is obviously now going to be exactly always less than the number of tasks. If that fails, then it's just a horrible error in the logic. I'm not even doing that third. Just let's write the correct code. We should be able to calculate actual number of tasks from understanding this this loop. Which means that this is equal to number of parents divided by the number of that, and then some round off problem error. The number of parents is never 0. So we run at least once, because we start at 0. Thus, if this equals number of parents per task, then we have exactly one task, namely for parent start equals 0, and then we add that, and now it's no longer less than, because it's equal. So exactly, this is exactly 1, the number of tasks is still 1. But if it is less than that, it should also be 1. In other words, like that. Number of parents is 0 now, then we have this minus 1 divided by that, which is 0. If number of parents is 1, then we get 1. Number of parents is equal to number of parents per task. Then we have 2 times number of parents per task, minus 1 divided by that is still 1. And if it is number of parents per task plus 1, then it cancels out exactly, and we have twice that value, and then we get 2. So this is the exact number of tasks, the exact number that we loop here. So now it's no longer running tasks, because the tasks are not running yet. It's unfinished tasks. And then if unfinished tasks becomes 0, then we're done. Yeah, I could add a tight loop in the main thread that waits for that thing to become null, but that would waste CPU. So it's probably better to just let the threads do it. Just do the decrement and then test it, and if it becomes 0, then we're done. Um, that's nonsense, of course. This is equal 1, so it was the last one. So I made this object called gate, and the gate is usually closed. And if you call open on it, then the gate is opened, and then all the threads can pass through the gate. So we need to create a gate here. Utils threading gate done. And then here we can just wait until the gate goes open. So now the main thread will wait here until the last task finished, and at that point we can copy all the vectors of all the different tasks to the final output vector. And the array is called that, it's the longest one, and that thing is called black to move parents. Okay. So we loop here over something, and then we copy it to black to move parents. Okay, how do I run over that thing? It was an array, so maybe I should just use an index. But arrays also have begin and end. You can just run over all the vectors using a range stuff. Going to read from it. Pin range. I could switch to 0 plus 23, but I'm still hesitating. Maybe it's time to switch though. I'm definitely going to do that if this is the way. No. It's just to use this ranges. I guess this copies a vec2 to vec1 at the end. I'm happy with copy because my board is nothing. Yeah, I think then we're done. Oh yeah, usually I call my gates until something something. So let's say until all tasks finished. Yeah, why not? Until all tasks finished. Wait. No comment needed. And this then is absolutely not readable. Until all tasks finish open. But yeah, you have to choose, you know. It's one or the other. Let's see if this compiles. Well, we didn't use that header yet. Well, why is gate not even highlighted? That's extra weird. Utils threading. Gate. Yeah, just this header. Arrow variable until all tasks finished cannot be implicit. Blah blah blah. Forgot to capture it. Also by reference, right? Because it's a thing that has a state outside of the task. Must return bool or what? Oh, it must be return bool. Yeah, that's true. Your task must be a callable thing that takes no arguments and returns a boolean. I forgot what a boolean means, though. I think success or run again. I think I completely forgot. Let's try to find that out. It's a void move in. Interesting. And then we don't have another. Well, this thing looks pretty successful and it returns false. I think I'm gonna return false. Do I really not have any documentation about what it should return? Secure access. It's a void thing. Huh, what? That makes no sense, man. Oh, I'm looking at move in. I'm an idiot. Move in returns nothing. Oh yeah. No, I have to look at what is being passed. Well, that's a T. Not useful. It's kind of weird that I can't immediately find what the return value of the task means. It's not even saying it here. The current last task moved out of the queue that this thread is executing. There, active. Yeah, so I think active means I want to be called again. Something like that. So I definitely should return false. Yeah, it puts it back in. If active is true, it tries to put it back into the queue. And if that doesn't work, if that does not succeed, then or it does succeed actually. If it did succeed, then the current thread keeps running. It's a bit vague. My memory, the ridiculousness of it. I designed and wrote this. And I'm acting as if I have see this code for the first time. Bad memory, I can't help it. Use of undeclared identifier a number of tasks. That you mean max number of tasks. That's in the part that I still have to replace, I think. Well, if it doesn't compile, I probably should replace it right now. Run over all positions. Replace black with white. And white with black. Cannot believe that that would not work. The rest should not need any change. Oh yeah. Oh, well, okay. Yeah, there is a difference. There is definitely a difference. Oh shit, and I deleted the code. No. Git diff. It used to do this. Right before the S that I deleted. Hello, Ibrahim. $302. Oh yeah, I have to replace minimum with maximum. Well, here anyway. And then this becomes a task apparently. The rest is correct. I think there's only one. Yeah. Now, cross fingers and run it. Do your program? No, no. C++. Inf chess. I think it hangs. It's definitely not using a 100% CPU. Oh, actually, those are the first 7 seconds. It's reading my disk. This takes 50 minutes with the real thing. Just reading it. That's why I bought new hard disk. Seriously, yes I did. And I should have gotten them today, but no, I was sleeping somewhere in the afternoon. And we crashed. 30 seconds to read the start. So my new hard disk is going to be... Well, I bought 2 hard disks. So in total they will read 14 gigabytes per second instead of 180 megabytes per second. How much faster is that? 14 divided by 0.18 is 77 times faster. 78 times faster. It's going to be a fraction of a second then. And under a minute for the real thing. That's the more important thing, of course. Yeah, this is already annoying weight, I have to admit, of saying. Now the big question is, did this work before, or is there something else wrong? Because, I don't know. I think it worked before, right? Before my change. I think I also committed it for a change. So the div that I have now is purely threaded. I made this one atomic. Thread stuff, all thread stuff, added ThreadPool. Divide everything up in tasks and add them to the ThreadPool. Also for the other color. And okay, an extra measurement, time measurement. So what I could do is add the time measurement anyway, because I wanted to do that. So just get add minus p. No. No. No, no, no. What is this? Yes. Just to start, right? Okay, so no, no, yes. And that was it. And then commit it. Print execution time. Another execution time. Yeah, yeah, well, execution time for print and execution time for generating the graph. So the number of ply. And I'm going to stash everything I have now. Message. What is M? Store. I could do store. Is it not the default? Push the default. Also M. Probably just need push to add a message. So compiled it without threading, and then if we run it, execution time, nothing. What? That took 30 seconds before. Everything failed now. Was my image file corrupted? It's not like I will see that here. Was it corrupted? I'm afraid no. The execution time is being printed already. Setting ply to 0 for 1920 positions. Is made equals ply 0 failed. This is weird in itself. But it should take about 30 seconds, I think. Just reading that file. Oh, that's even faster. It immediately coordinates. I don't think it touched this file. It did not touch the file. No. But what is going on? Maybe I made another change, which I just reverted. Apply 0 is made as not true for which position? I guess if this fails, I should print the position, so I know if this makes any sense. So hardly useful to print this, I think, but code is 0. It's illegal position even. Yeah, that looks pretty much like an illegal position, to be honest. Not enough bits. Or, maybe I'm wrong. Guess this has the black king at in the corner, 0, 0 here. And then the white king is, this is the white king and this is the rook. Why would that be, so it's yx. So the rook is at 2, 0. No, 0, 1, 2. Yeah, and the blacking there, and then that should be at 0,2. It actually looks like a legal position, which means that the memory mapped file it did get corrupted. So maybe filled with all zeros or something like that. When would that have been happening then? I don't get it. Okay, let's uncomment this so I can actually see it, but I'm pretty sure this is correct. I mean, why would this not be correct? 175. Yeah, that's what I envisioned. So it is a legal position, provided that it is black to move. Yeah, we get a black to move info by passing black to get info, which is the one that is to move. To move. So black is to move. And it's totally legal position, and yet we get that is an illegal position. I'm gonna guess that my map file is all zeros. It's literally all zeros. That's all the way till the end. Who did that? That's not good. Okay, let's remove the file. I don't know. It's kind of weird. And now I'm running in debug mode, which takes about 100 times as slow as the optimized version, so we can't wait for this. Let's not do this, it takes too long. I think the optimized version took 30 seconds, we can wait for that. So I'm gonna remove this one again, and then edit this again, and then use the beta test version again, load that again, configure it again, build that again. Wait 31 seconds. Now it should be recreating this file with non-zero stuff. She's all. Yeah. It's a bit too difficult to explain step by step. I have a memory mapped file with I think 2 bytes per position, where each position is a position of a quarter infinite board, or well, infinite between quotes because it's 32 by 32. With a white king and a white rook and a black king. So the number of positions is still quite big. So if you well, it includes illegal positions. So basically, the number of squares that the king can be on is 32 times 32. There's 1,024 possibilities for each piece. So there is 2 kings and a rook, so roughly 1 billion 1,024 to the power of 3. Different positions, and then for each of those I store 2 bytes, which should include if that particular position is mate or not, or stalemate, or draw, or black is in check, and the number of ply in which that particular position is made under perfect play. And the worst possible position that you can put on the 32 times 32 board, it takes 292 ply before it is made. And I'm calculating this by starting with all positions that are made, which are quite easy to calculate. It's just the black king on the edge, and then the white king opposite, and then the rook gives check. And then I calculate. I have a position, so I can calculate all positions that can reach the mate position in one move. And I used to store that, but it takes. I mean, we have a billion positions, so it's just. I really don't want to store more than just the 2 bytes that I just talked about. So having the index into my 1 billion big array, the index itself encodes the position, and then I just calculate again and again and again what positions can be reached from there, or which positions can be preceding, so that from which positions we can reach the current position. So if you go backwards, I would calculate all the parent positions, and then if one of the parent positions is has not determined how quick it is made, and in the parent position it is white to move, then of course white is going to do that move. So we end up in the current position where I know how many ply it takes to give mate. And then the parent position is 1 more. So the parent position is 1 ply more, because white is going to do that 1 ply, 1 move, and then we end up in the position where I know how many ply it is. And so we work backwards. And that takes many hours. In the end I want to work with the 64 times 64 board. I don't think I can do larger. So, and since it's not working, I'm doing it in steps. So first I classify each position, as in if it is mate, stalemate, draw, check, etc. And then I calculate the ply. And all this information is written to this file, or to this file actually. It's a memory mapped thingy. So I had the classification already, and then it failed. Well, actually, sorry, the calculating the ply is then done by Okay, what's happening? Yeah, this. So the ply gets higher and higher because every time, you know, we find all parent positions from which we can reach the previous position. But this is slowing down, as you see. It takes some time. So I added threading now. I added a thread pool and then divide all these positions into tasks, around 200 tasks, which I then add to a thread pool, which then do a part of this loop. So the loop here is like 10 million already, or 5 and 6 million here, but the largest one is 10 million. And each of these again run over all parent positions, which are quickly 64. For the rook can come from somewhere on that row or somewhere from the column. So that's already almost 64, and then plus 8 or so, or 7 or 8, I guess, for the king move. So that's really suitable to do in a thread pool. So many threads in parallel. And I just coded it and I did run it and then it crashed. And then I removed the threading code that I just wrote. And then it also didn't work, which turned out to be because my memory map file was all zeroed out. So now I just generated that again. So now I'm running it without the thread pool. And it seems to work. Which means that it's gonna take a long time, man. Probably too long. Yeah, it's just now not really chess. I mean, chess rules-ish, but the board is very big. At the moment it's a 32 by 32 board. And then 2 edges don't exist. So you can't give mate against those edges. If you go over the board on 2 edges, then the program is considering it unknown or well, I don't know, pretends it's a draw. But it's never a draw, so that's just wrong. So I have to stay away from those virtual edges. We have only 2 real edges, and it's a quarter infinite board. And if you're far away from the virtual edges, because my memory is limited and the board is not really infinite, you're far away from those, then it will do then it will give the right answer. So I need at least 64 by 64, so I can stay far away from those virtual edges, and then get the correct answer for how many ply something is made. And I'm going to analyze stuff with using that. But okay, the problem at this moment is that my file got corrupted. I think I'm going to make a copy so I don't have to run this again. I'm not happy. We can already look at that. Get maybe an idea why the file got corrupted. Because this is gonna run till 255 and then maybe even another one. This is for one color. I think these are the positions for the that are made. See, this is how big the board is now, 32 by 32, and this is a made position. So 1920 positions that are made. I really don't get why it got zeroed. Because, yeah, I look at the file exists. Now the file existed. So this is going to be true. Therefore, we don't have to create a directory, and I'm passing true to graph. And then, because the file already exists, this data should be in there. So we don't have to calculate all this. you see this? So that this determines if a position is draw or in check or is maintenance or stuff like that. Call that classification. We don't have to call this because it's already classified, because the file exists. And that works. So we skip this part, but I still need all the positions that are made. So I'm generating quickly, put that in this vector here, all the positions that are already made. And then I'm starting with calling set made imply 0 on all those positions, changing the classification, but that should not change the apply is now also part of classification. So this should not change the classification, just apply. If the whole file was zeroed out, then the only reason I can think of is that that is being done by the graph object itself during construction. I mean, nothing else is doing that. Everything else should leave the classification alone, classification bits. And if you look at the graph, passing reuse file is true, then we construct the memory map pool with a false here. It's more complex than that, I guess, but also this, yeah. This is constructing a partition type in place in a virtual memory where the file is mapped to, and that should not touch it. But the partitions type should do nothing, so it should not fill it to zeros or something like that. This is an array. If I construct an array, it should do nothing, I think. Well, call the constructor on each element, so it would call the constructor on nodes type, which is also array, so it should be called the constructor on info with initialize false there, so it should do nothing. I mean, yeah. I mean, that's my thought. If this went wrong, yeah, okay, well, I'll fix it, and then I'm mistaken, but. Guess you'll have to test it out. My memory map pool with 0 init being false. I mean, the only thing that can set it to 0 here is the call to fallocate with this 0 range, or maybe whatever fallocate, but this is not being called, this fallocate, because file exists. We only do that if the file did not exist. And this one should not be called because 0 init is false. That's the only two. I'm just not getting it. And this is gonna take forever. Maybe it's faster if I put this back from backup. I think I have those values in my backup. Sometimes I have to practice the backup, you know, for the case that I really need it. Pardon the small font. Let me think. Backup. So I think I would normally go to /user source arch, and I have a how-tos here. and that has Borg. And that tells me where the repository is, to list all available archives, to recover a single file. This is what I should do. Repository path, blah blah blah. Okay, let's keep this open and then run this. And then I have to type my password. And then I typed it wrong because you guys were listening over my shoulder. I blame you guys. How long is this going to take? Seriously? Maybe I typed it right, but it just takes long. Well, boy, that's using the same hard disk as I'm already pounding on. This hard disk is pounded too much. So I think I typed the password correctly. And then it tried to access my backup on the same drive as I'm molesting at the moment. Soon we'll have no backups anymore because the drive is broken. And even Control C is not working. That's very annoying. So some Python script. This Python script is waiting for the disk. It's the D here. So it will probably recover if my program finishes. I think I can safely kill it. Can I not? Because I killed it already anyway. Kill, sure, I don't know. So let's start with int. I have to do this as root. So I think it's running as root. Still not doing anything. I'm just gonna kill it, like really kill it. So that worked. Yeah, well, I don't know. We'll have to wait till this finishes. I think it goes to 255, or this already gets less now, so we're almost there. But I think it's gonna start it again for the other color. Oh, it's going past. There's 292. That's what it is. Yeah. Max supply, execution time, entering memory map pool. True. What? Okay, this sucks. This is a init initialize with zeros. True. It's doing it again. No. What? So I'm creating a second graph where I reset the whole file again. This makes no sense. I'm creating a second file with false. Oh, fuck. Yeah, that's it. I changed the meaning of this thing. No, wait, I didn't. No, this is file exists. False. File exists. Yeah, file. Yeah, I changed it. This used to be 0 initialize. So I create this test graph with do not initialize it. And then I changed graph to take a reuse file. Now it's reuse file. So the boolean is swapped. The meaning swapped. So this should be true. So now I'm generating it, and then this test here is immediately erasing it, and then we end up with an empty file. And the test seems to succeed because after that I compare both. I compare both graphs, which are both backup by the same memory mapped file, all with zeros, meaning every position is illegal. Hey, yes, they are the same. All positions are illegal. No, this is the reason. Okay, so let's quit this thing. Just stop running. I think it's writing to my disk now. All zeros. It's writing all zeros to the disk. There's no stopping it. Sorry, Sujel Kushal said, you are bi? I don't know what you mean with a bi developer. What does your sexual orientation have to do with it? I'm just kidding. I know some code, but not C++. Should I learn it? What do you say? I say nothing. I mean, you can learn it. But I would only do that if you are super enthusiastic about, oh, wow, C++, that looks cool. I want to learn it. Yeah. How did it go for me? I was coding in C for a long time. Why did I start C++? It's a good question. Not even really a good reason, I think. I have no idea why I started to look at C++. But at the moment I did, I was like, wow, this is how I think. I was trying to code in C++ already while I was coding in C, if you get what I mean. Object-oriented and just the whole make your code robust and make it hard to introduce errors, kind of stuff. And I didn't know better. And if you code in C, then it just everything crashes. You never can get it safe. And then I learned C++, and I was completely sold immediately. So much better than C. Yeah, well, yeah, I don't know. All the really good coders that I know started at 12. But, I mean, I started at 12 too, but there didn't even exist PCs yet. So I started to code in BASIC, GFA BASIC. Still, I did write programs, pretty complex programs as well, that played games like Othello or stuff like that, or calculated all prime numbers, but I did it in BASIC. And I learned C. I started to learn C at a very old age, actually. So I think picking up a new language doesn't need to be a problem. Because I think I started coding in C for serious when I was already in my 20s as well. And C++ even later. I've been doing C++ now for more than 30 years, but yeah, I'm 61, so I might as well have started when I was 30 with C++. So that's not too late for that. The way you say it, I've been programming 2 years, but I feel like I'm not good yet. It still isn't totally nature, blah, blah, blah. It feels like you are very good and you have the potential to become a really good coder, I think. But just based on 2 sentences, so don't take my word for it. But yeah, 2 years is on nothing, of course. You just have to keep going and going and going. And you can never motivate yourself with future results. You must be motivated by in the moment thing. If you constantly, if you try to lose weight, basically, and you every day you go stand on the weighting measurement thingy, how is that called? Weegschaal. That's not how you do it. You know, you just change the way you eat, and then you stop thinking about it. I think it's with coding the same thing, or anything you want to be good at. You have to do it a lot, but don't continuously look at how good am I and where am I going and am I there yet and why is it going so slow. I think one of the reasons that I got till where I am now in terms of I'm on my way down, by the way. I'm so old that everything is degrading. But the reason that I reached the heights that I used to be at a decade ago or so is, among other things, because I don't have deadlines. I just decide I want to do something, and then I do it, and I do it good, and I really don't care how long it takes. Well, I think if you have something like I must, reach a certain goal or get a certain level before this or that time, then you don't take the time that is needed to become hacker level good at it. Hacker level meaning you're just the expert in the world. You know everything. You went to the bottom, to the last bit. You're never happy with doing it halfway. It's kind of like this program. This is even the last program that I wrote. This project, it's completely insane. The amount of time I put into it. It's just a bloody end game on not even on a real chessboard. Why am I putting 3 months of into this and buying new hard disks just for this bloody project? Because I can't help myself. I just wanted to do this the best way. And sometimes it pays off. For example, if you look at my prime generator thing, which I also wrote in the past few years, somewhere. So if you go to the repositories, my repositories, I have something with primes. Fast prime, that really is fast primes. What is it? Yeah, this is not it. I don't know why I even leave the readme up. Should go to fast primes, the module. So this allows you to generate all prime numbers up till 1 trillion. with just 24 gigabytes of RAM. This is insanely complex and difficult, and I put everything into it that I could. And now I have the feeling that you can't write a better prime generator than this. This is it. This is the end station. If you need anything that runs on a normal PC that generates primes, this is it. Don't look any further. And that gives me a good feeling. But I put, of course, insane amounts of time into it. And it is super complex. It ended up, I called it a compressed sieve of Eratosthenes. Although I kind of made it up myself. Hell, I made up the sieve of Eratosthenes myself when I was 15, I think. I didn't know the guy, but they could, maybe they should rename it. He has gotten his name on this long enough. From this moment on, we're going to call it the sieve of Carlo. Because I never looked at this Eratosthenes work. I just made it up myself. And I have to say, this is true for a lot of my repositories. I'm also especially proud on the thread safe one. I mean, in terms of this is perfect. You can't get it any better in my eyes. It's not even here. It's called thread safe. But most of these things, yeah, they just work, and there is no reason to try to look at it or have an idea. Maybe it's not good. It's just good enough, really. If I go to a random guy's repositories on GitHub and I see that he wrote some library, then my first feeling is, yeah, but is it really good? You know, I mean, anyone can write a library, but maybe it's 100 times slower than it should be, or maybe it's a factor of 2 slower than it should be. Is it really written efficiently? Blah, blah, blah. So don't think that for my code, please. If I write code, it's going to be better than you will ever write it. Especially fast, you know, in terms of fast, robust, everything. People should just be using my code. But I have a shitty license, apparently, I think, some open source license, not usable for business. And I hardly write documentation. I mean, the documentation is in the source code, but nobody can find it. You click on something, yeah, AI math test suite. Maybe you want to do something with math. README. Oh, okay, let's search for another math library. Well, and if you're smart, maybe you click on the actual thing, math here. And that tells you that there is this stuff in it. Yeah, if this is all the documentation you get, a single word, analyze cubic. Cached analysis of a cubic polynomial. One of the local extremes and the inflection point. That's the whole documentation for the thing. You don't know what it is doing. You don't know if it is good. You don't look at this and think, this guy did a PhD on cubic polynomial analysis. But that is what it is. I put an absolutely insane amount of work into polynomials, especially cubic polynomials, and solving it and stuff like that. I have the proof because all of this has been streamed. So it's still on YouTube, but you can find back the 2,000 hours that I worked on this somewhere on in my live streams. And I have 0 forks and 0 stars. Yeah, I don't know. That's how it is, I guess. I completely gave up on getting people involved with what I do. Did we finish it? Yeah, okay, it stopped. So now I have to run it again because it zeroed out my file again, right? So have a hex dump hex. What was it? X something. If I knew that command line a little bit better, I would only listed the first kilobyte or something. Oh, that's it. It was pretty fast. Yeah, and this is again full zero, so that's just really stupid. Yes, yeah, that's true. I like mathematics. I did not study mathematics, but I did do some stuff. I'm not shying away from it, so there's a lot of mathematics in it. You say what is motivating is seeing past results, though. I don't think for me that was ever the case. I was always obsessed with the very thing I was doing at that moment. So when I was writing a program that played Othello, I was the whole day thinking about the specific part of the algorithm of that game that I was writing. I'm not thinking about anything else. I mean, certainly not. I want to become a good programmer or anything like that. I wouldn't care about that. I just cared about getting a very good program. That program. And then once that program worked, I lost interest, and then I do something else. I had another idea. Oh, let's write this, and then I would make that better and better and better and even better, and then write 3 versions until it was perfect. And then I would go to the next project. Never with the intention to become good or something like that. I think that would hold, in my opinion, that would hold you back. You just have to start, not think about it, and then 10 years later, if someone asks you, I don't know, after 10 years, you can think about it again, and then suddenly you realize, I've become quite good. Now I think about it, if I compare myself to colleagues at work, everyone comes to me with questions. Kind of picked something up, I guess, in the last 10 years. Thirsty. I will never be able to forget this number again. 661234. So the next time I see these numbers and you see me 269, yeah, I mean, sorry, but so the next stream will see this and I say, oh yeah, I remember that. The 50 I already remembered, actually. The last one was 50, yeah, I know that. I'm gonna run it again. I did fix it, right? Just before I didn't fix it. Of course I fixed it. I just fixed it. Graph G or not. Interesting. There is another graph. It's called G. Maybe it's const. It's const. That's why. 2 meaning reuse file. Okay, I'm happy. Compiled it already. Let's run this again because still no file. Yeah, so that is the error that we got, and that is because my file exists, but it is all zeros. Let's molest the disk again. Poor hard disk. Oh, that was my opportunity to get it from my backup. Or maybe the backup was all zeros as well. Probably going to take as long as last time, which was... I can't remember. I have really no clue. Can you remember how long it said? Execution time for the last thing that last time I did run this? That wasn't here, was it? No. No, this is where I compiled it. Actually, there is one here. This one didn't have execution times yet. And this is probably 1920 of these beasts. Oh, it's right here, 865. Ah, okay. So it's going to take that time again, which is, I don't know, how long is that? 15 minutes, 40 minutes. I'm almost out of theory. I don't think I want to let him take it. But, well, want to. It's more like the theory is, I think I don't want to let him take it. But, yeah, I can then... this should keep this a backward spawn, so I would have to take with the queen, and then I could chase my queen away. And then the queen has to move again, and then he can push the pawn, because then it's just 2 against 2. So he would resolve this weakness. And if we go away, then it is no tempo loss with my queen, and he can't immediately push it. So you go here. And then black is trying to exchange this bad bishop because this is on black for my knight, and well, they are not. Well, I think that's possible, and then I play this because he can't take it, preventing him to come here. And if he takes it, he just loses a piece. The queen comes here, and so that's still theory. So I'm still playing like a grandmaster here. It's about the only opening that I know pretty well. I don't know what the best move was or is here though. Okay, why is he doing that? No reason. Suppose he might want to go here and then there, but that would 1, 2, 3, 1, 2, 3. It's even possible. I think I want to. Now this thing has to be played. They just play it here. Nah, this makes no sense. I block my queen and I'm just watching against my own pawn, and this is not possible. The sacrifice is also nonsense. I guess this is the square, right? The square where we have to develop to. This guy is still working very hard on pushing this pawn. Probably too late stopping it, but I could now play my knight here and then knight here. Take, 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 and then my queen is here. And he cannot chase me away with the knight because he exchanged it. But he can chase me away then with the rook. And then if we go back, he has the rook and the queen here. And then he can push the pawn. Still, again. Unless my bishop would have been here. How about I do that right now? I put my bishop here and he cannot push it because it is 1, 2, 3, 4 against 1, 2, 3. So this maybe this, and then he puts a rook there, and then I can do this knight move. Because say rook here, knight, and I just go here, take, 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 take. Queen comes here, and he chases my queen away, and the queen goes back, and he still can't push it because then I have the queen, pawn, and bishop on this square. So I really block. Well, he can push it. No, he cannot because my bishop is on it. So he has a rook and a queen up front. So if he pushes it, I would just take it. It's already playing this. Is this guy looking at my stream? Okay, if now I go here, and he takes, I take, he takes, I have to take with the pawn again, which is definitely not what they wanted to do. It is highly annoying. This is a very good move. Suspiciously good move. But okay, I won't call him a cheat because it makes sense to attack this square again. Does this move? I take, 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 take. See, this is not good. I don't know. I feel I'm gonna lose tempo here. Or maybe I should have moved this, attacking the pawn, and then he would attack my knight, and then he go there, attacking the rook. That would not have been bad actually. I can still do that maybe. Again blocking, again blocking my queen then. But okay, the rook is gone. That's something. See, 1, 2, 3, 4, 5, all aimed on this square. And I have only 1, 2, 3.5, 3.5. Yeah, that's not good. That is not good. I'm one tempo down, really. Ting, 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 and it's not good. I have to move my knight, and even then... No, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. If I move it, I can't castle after that though. Shit. Wait a minute. I have something here maybe. So it comes forward. Take, 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 take. Queen is here, and then the queen is not defended. Well, not enough. It's not good. No, it's nonsense. It's nonsense. Yeah, and this is also not good. Fuck. I should never have castled that way. This looks horrible. No, what a horrible thing. You could play my knight back here now. If the rook goes here, but not immediately, and it would be pinned. The king has to go to the side. You could give check to this side, queen here. No, it's well defended actually. Now I want to move this knight over here and then over there. That would be nice. Take that, everything. Yeah, and I'm winning on time. That's a good thing. I'm getting a piece. No, not really. Getting a pawn. This guy is not looking at his clock. Oh, fuck, the spinned. Oh, don't tell me I'm losing. I'm so losing now. This is ridiculous, of course. I'm waiting on time. But, my god, horrible. And you can't type a sentence or they leave already. Yeah, that's normal. This thing is still running. Yeah, I think I'm going to stop the stream because it's just that time. It's annoying that it takes so long. I was going to, I wanted to test at the very least my ThreadPool. Guess I could continue for another 1.5 hours, but don't have to go to bed. Get faster. It's getting faster. So every other is it's really fast already because then it's black to move. There's only a few possibilities. If I had a smart way to compress the rook moves, because often it doesn't really matter where the rook is, just somewhere on that row. But I'm stupid these days, definitely. I just can't think of a way to compress that. So if the board was really infinite, then I would have to compress it. Maybe that's the way to go. Just forget about having a finite board altogether and just say it's just infinite. Period. Well, the kings must be finite, but the rook, in terms of the rook, have an infinite board, really infinite. And then, of course, you have to store something like, I don't know where the rook is, but somewhere on that row, far away. But yeah, then the problem with that is that I have to calculate backwards. So that then the question is, which parent positions would allow me to reach this position where the rook is somewhere on that row. And then the rook is therefore somewhere on that row and then perpendicular away from it, or maybe still somewhere on that row. Well, that wouldn't be a very useful move, I think. The rook probably moves perpendicular usually, unless it's very close to the enemy king, to cut off the king. But you're not sure about it. It's just a hunch, and I want to be sure. I want to do this brute force with no room for errors, for I mean, especially the special cases are interesting if they exist. But yeah, I'm not sure if you can, if I can compress the place where the hook is. So every time you move perpendicular somewhere, and then you have to. First, it's a whole line where it can be. Then it's a whole rectangle where it can be, or an infinite rectangle already. And then the before that, it can be anywhere, literally anywhere, to end up on that rectangle. Well, except the rectangle. This is it. This is it. Look at that. Now we have a non-zero file. I'm gonna calculate the MD5 sum. So just at some point be 100% sure that it didn't change. Probably not very useful actually. Because, well, this is useful. Multiply are filled in as well. So let's say this is the canonical answer. Save that. Paste it on Discord. Ding, 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 ding. Ding. Oh, I could have pasted it as well. And next is testing this with the ThreadPool. Git stash pop. Change is not stage or commit. Your local changes, blah, blah, blah. Diff. Definitely want to remove this. Comment it out again, or git restore -p. Oh, wait a minute. Actually, I want to test without threading that it works while the file already exists. I just generated it. Okay, totally worked. Now this is the time to generate positions that were made already. It's immediately testing though. It's a bit... thought it would recalculate the number of ply. I mean, that's what I need to test anyway. Testing contents, execution time, max supply is. I want this to be executed. Why would it not be executed? Setting apply to 0. Second execution time. Do the whole thing. Well, it didn't print this, did it? Did not print this. Why? But it did print this. Okay, now I have no idea what is going on. Testing. What the hell? It's a see out thing. Oh, debugging is off. I don't even have debug output. That's the reason. Probably should flush it. Still not printing it. And I do have debug output. What the fuck? You see, it's time to go to bed. But what's going on? Why is it printing this and not the other things? The only difference that there is that now the file exists. Try blah blah, file exists. So if file not exists, we do this. We do not do that now, meaning that we generate all the made positions, and then it should print a number of made positions, and then the execution time, number of made positions, execution time. Set apply to 0, print set. Okay, the second execution time is also 0. That's concerning. Yeah, that's the reason. The loop is just completely empty. So this is being done, I think, very quickly, and now this is empty. In other words, the y to move parents is empty. Well, not empty. We do something, but it is empty, and therefore max supply should be printed though. It's not printing it. Oh yeah, it is printing it. Max supply 0. That's wrong. Why is that being printed as 0? Because this is empty. Why is that empty? Because this function is not writing anything. I think the function is not writing anything because all the plies are already calculated. Yeah, that's it. So to test this now, I have to reset the number of ply. I calculated it and put it in the mapped file, but I want to run this again without running the beginning again, the classification. And this is just not working. Let's see, yeah. Like to move set maximum ply on parents is doing the following. See, it is only writing when the parent ply is unknown. Maybe I should also accept for the moment anyway. If parent ply is equal to what I try to set. Oh, this is way harder. Was this the last child? Well, that might still work. That might still work. I think that still works. So 296 should now be 661234. Or record dump. That's also possible, of course. Wait a minute. That's just an assert that demands that it is unknown. I'm going to have to remove that one then. Call white the most in that case. I think I can safely comment that one out and still have it work. Nope. Number of visited children less than number of children fields. So I do get here too often now. Ugh, okay, I give up. Well, so alternatively, I run over all positions and just set all the ply to unknown. Just to be able to test this. How do I do that? Number of bits is 5. Okay, so that's these 5 here. So bits mask is that's the real classification. So I want to keep that. So it's like this. Just keep the bits. So yeah, now it's resetting all those splice. It's just going to take a while. It basically writes the whole file again. It shouldn't take longer than calculating the MD5 sum, which didn't take that long. Yeah, there it is. I guess I didn't reset this. Number of children. Probably have to do those still. I believe that was the error that I got after testing the ThreadPool for the first time. Damn it, still doesn't work. This must have been on initialized memory. Now it complains about that the number of children isn't larger than 0. I just set it to 0, but it probably happened at a different moment. Yeah, or this is normally set during the classification, and I'm skipping that part. Oh shit. Info. Uh-oh. Uh-oh. Yeah, I corrupted the memory mapped file again. So I should not have reset this one. Just that one. But I did. So, and I did not make a backup of the huge file. Arrgh. I'm so stupid. Yeah, this gets set during classification, I think. Number of children is number of children, set number of children. It's being called here. which is part of classify. Should not have touched that. Oops, I did. Let's go to bed. Because now I have to run it again. I should have made a backup. This is of course completely corrupted now. So I did make the MD5 sum to test if it was corrupted, and then but did not make a backup. Copy. It's not all zeros though, is it? Just testing. Just wondering. It's not all zeros, no. Okay. But. Yeah, okay. Well, tomorrow another day then. I'll go to bed.